You will have noticed that a discussion of division was missing from our work in complex number arithmetic. And the reason for that is that in order to divide complex numbers, we needed the machinery of rationalizing the denominator. Here's why. Suppose we want to divide 2 plus 3i by 1 minus 3i. In order to do this division, we write this in fraction notation. Now the reason that we can't do anything more with this is that we have two terms in the denominator. Because we have two terms in the denominator, we can't just go ahead and do division. Because two terms in the numerator, that's fine, we can just distribute the division. But if I have two terms in the denominator, there's just no way to get that split up. However, if we remember that this is actually -3 times a square root of -1, and we think, let's rationalize the denominator. Well, if we got that -1 out of the square root, we wouldn't have any problems, right? Because then we would just have numbers in our denominator, real numbers, and we could actually add or subtract them. So we have a minus b. We want a squared minus b squared. So we multiply by a plus b. We want to multiply our denominator by 1 plus 3i. Whatever we multiply our denominator by, we have to multiply the numerator by the same thing. So then, in the denominator, we'll have 1 squared minus 3i squared. In the numerator, we'll have, let's see, 2 times 1 is 2, plus 2 times 3i is 6i, plus 3i times 1 is 3i, plus 3i times 3i is 9i squared. So working this out and remembering that I squared is -1, we'll have 2 plus 9i minus 9 over 1 plus positive 9. Minus -9 is plus positive 9. So we have -7 plus 9i all over 10, which, if we just distribute that division by 10 now, we get -0.7 plus 0.9i. What does it mean to say that we've accomplished that division? Note, if 2 plus 3i divided by 1 minus 3i is -0.7 plus 0.9i, then if I take my quotient and multiply it by my divisor, I should get my dividend back. Let's confirm that that really happens. So we take -0.7 plus 0.9i times 1 minus 3i. That gives us, well, -0.7 times 1 is -0.7. -0.7 times -3i is plus 2.1i. 0.9i times 1, that's plus 0.9i. And then 0.9i times -3i is negative 2.7 I squared. Remembering that I squared is negative 1, we have negative 0.7 plus 3I plus 2.7, and then combining those last two like terms, we really do get 2 plus 3I. So that really does work out. Now a couple of things to note. This move, where we take a complex number and reverse the sign in the middle, is so common that it has a special name. If we take a complex number and reverse the sign on the imaginary term, that's called taking the complex conjugate. So the conjugate of 1 minus 3I is 1 plus 3I. The conjugate of 4 minus 6I would be 4 plus 6I. The conjugate of negative 2 plus 5I would be negative 2 minus 5I. In general, if we have A plus BI, its conjugate is A minus BI. If we have A minus BI, its conjugate is A plus BI. This comes up a lot. We often refer to pairs of complex conjugates. And part of the reason for that is, when we multiply a complex number by its conjugate, we get a real number. In particular, if we take A plus BI times A minus BI, we get A squared minus BI squared. Or, remembering that I squared is negative 1, we get just A squared plus B squared. Now, you don't need to memorize this, because just multiplying the whole thing out will get you there. However, you will find it much easier to work with complex numbers if you do memorize this. That a complex number times its conjugate gives you A squared plus B squared. It's also the case that if we add a complex number to its conjugate, we get a real number. So, if we take A plus BI plus A minus BI, well, you can see what happens. We get 2A plus 0I, so just 2A. Again, you don't have to memorize this, but you might find life easier if you do. All right, bringing this back to dividing complex numbers. I'm going to show you another example, and then I'm going to give you one to try. Suppose we want to take 3 plus 2I divided by 2 plus I. Well, first I'm going to write that in fraction notation. And now I want to multiply 2 plus I by its conjugate. Whatever I multiply my denominator by, I have to multiply my numerator by the same thing. In my numerator then, I have 2 times 3 is 6. 3 times minus I is negative I. 2I times 2 is positive 4I. 2I times negative I is negative 2I squared. In my denominator, I'll just have A squared plus B squared, so that's 2 squared plus 1 squared. So 6 plus 3I, remembering that I squared is negative 1, that's plus 2. In my denominator, I have 5. So I have 8 plus 3I over 5, which is going to be 8/5 plus 3/5 I. When we want to write a complex number for our answer, we want to write it in the form a plus bi, so that we can just look at it. And see what the real part is and what the imaginary part is. Okay, I'm going to let you try one of these now. Take 6 minus 4i divided by -1 minus I. Pause the video and try this now. Okay, so we begin by writing this in fraction notation. Now we multiply the numerator and denominator by the same thing, and what we want to multiply by is the conjugate of the denominator. So we leave the -1 alone. Minus I becomes plus I. Whatever we multiplied the denominator by, we multiply the numerator by the same thing. So in the denominator, we'll have -1 squared plus 1 squared. In the numerator, 6 times -1 is -6. 6 times I is 6i. -4i times -1 is positive 4i. And then -4i times I is -4i squared. So we'll have -6 plus 10i. Remembering that I squared is -1, we have plus 4 all over 2. So we've got -2 plus 10i all over 2. And finally, distributing that division, we get -1 plus 5i. And that's the result of that division.